Let's look at an example of how we can set up a keychain. Now, I want you to realize you're going to see an example of this again when you look at EIGRP authentication specifically, which relies on keychains for its authentication process. So if you're struggling with it here, you will see a demo of it, and you will have the ability to review it another time shortly within another discussion. So keychain specifies the name of the keychain. So we're creating that keychain. It's called router R1 chain. Doesn't have to match with R2. R2, we could have any name for the chain that we want. Inside of our keychain, we're going to have keys. Just like on a keychain, we have keys. Well, here we have key 1 and key 2. Now, these keys have to match with R2. So R2 would also have to have key 1 and key 2 specified because that key ID is used during the process of authentication. So, for example, if you're using hashing authentication, then this key ID is going to come into play during that hashing process. In addition to that, the key string comes into play. The key string is the string of characters that are going to be utilized along with that key ID in the overall hashing process and the algorithms and all that fun stuff in order to generate the hash in the end. So the key string is going to have to match as well on R2 when we set up R2. So the key chain doesn't have to match, but the key and the key strings do have to match between routers that want to form neighbor adjacency or exchange routing information with each other. We can also set up the accept and send lifetime, and this is where the key rotation comes into play. So if I want to utilize a certain key in January, I can do so. If I only want to accept a certain key from a neighboring device in a certain month, I can do so. You have the flexibility based on time and date. So in this example, you can see that we are accepting key 1 from a neighboring router from 4 a.m. on January 1st, 2014 to infinity, meaning it's never going to expire. However, we're only going to be utilizing or sending key 1 from 4 a.m. on January 1st, 2014 to 4 a.m. on January 31st, 2014. So it's going to expire at the end of the month in this case. Key 2 is then going to have to come into play at some point in time because after January 31st, we no longer have a key that we can utilize for the authentication process. We won't be sending anymore. So here they have an overlap set. And on key 2, R1 is saying, I'm going to utilize this key from 4 a.m. January 25th to infinity. It's never going to expire. So if you look here, we have an overlap of a few days from January 5th to January 25th to January 31st for the send lifetime of these keys. Now, key 1 is still going to be the valid key all the way up until January 31st. So up until January 31st, 4 a.m. 2014, key 1 is going to be used because it would be the first valid key in our list that we can use for authentication. But then after 4 a.m. on January 31st, we will then start to use key 2 at that point in time. So you might be asking, well, why the overlap? Well, if something happens and key 1 is no longer available in the last 5 days of the month, well, then we still have key 2 that can come on board and take over and be utilized. Also, we were saying that the transition process, we want to make sure it happens seamlessly. So we want to ensure that the transition process does not disrupt a neighborship. Right? We don't want any packets to go unnoticed, or pardon me, not unnoticed, but we don't want any packets to be sent with the wrong keying information or sent with the wrong hash, and then all of a sudden authentication fails between the two routers. Think about OSPF. Think about EIGRP. How often do they send hello packets? EIGRP is every 5 seconds, which means that we have a 5-second window of opportunity to successfully change keys on both devices. Now, I'm not saying that we need 5 days here. They're just showing you this example, but in reality, we could have set up the send lifetime for key 1 to expire January 31st at, 4 a.m., and then have key 2 come on board a minute before that. Just a minute, and that would be fine. Because a minute before, right, we're going to have key 1 still being used for that entire minute. Then right at the top, when it expires, key 2's already valid, and that's the next one being used. And R2 is using key 2 as well at that time. and everything's good. The transition is seamless. Neighbor adjacency doesn't break. Routing updates are still great. So we have the ability here with our keychains to take that authentication and make sure that we are rotating through keys and having a much higher degree of security within our routing protocol authentication.